All right. That's everybody there. Screen. Check one other thing. Okay. All right, looks good. All right. Welcome, gentlemen. Give me one more second. All right, so we are here. You've done it. All right. This is it. So this is our last official lecture, right? This is the last time we're going to take attendance. Our last time I'm going to take attendance. So today I was going to go through as much of exam 3 together as we can. You can anticipate your final exam to become available this upcoming Sunday at 11:11 a.m. It'll be due the following Friday at 11:59 p.m. So next week, I do intend to be on the Zoom call during class time. Basically from 9 to 5 on Monday and Wednesday. I might have a 1 to 3 hour gap in the middle of the day. But yeah, next week during the finals, I'll be available on Zoom from 9 to 5. I'm not going to take attendance. I'm just going to be there just to make myself available. You're not obligated to attend next week. Again, I'm just trying to make it so that you can find me if you have questions or if you need help with any like last minute things. So when the final exam is due next Friday, a week from this Friday at 11:59 p.m., remember, that's the hard deadline. So not only is the final going to be due, but everything is going to be due. So that means that on Saturday morning, I'll start calculating final grades. The goal is when you submit your final exam, that should be it. You shouldn't have anything lingering or trying to submit anything after your final, all right? So the final is supposed to be the last thing. A similar format to all the other exams, unlimited attempts. The system is set to take your highest score. You get unlimited attempts for 5 days, right? So I know you guys can do it. Yeah, and I just want you to take a moment. I'm proud of you guys. All right, you deserve a pat on the back. This is not easy. Doing remote work, classwork is not easy because you got to have some level of discipline. You have to show up every day. It's very easy to not show up, to be comfortable, to not make a plan. But you made a plan, you executed whatever the plan is. It's okay, as long as you did what I asked you to do. So hopefully you were able to position yourself for success. Hopefully you were able to learn something and grow something about yourself. You were able to grow as an individual so that you can get out here and, contribute to society on some level. Yeah, so let's just take some time. Let's see what we're looking like. So for exam 3, you logged me out. I thought I had just logged in. Maybe I did. I'm not gonna lie. I totally just got a Ninja blender for Black Friday because I had been waiting for like months, and then I realized I was like, okay, this thing is moving like extra slow. I knew if I didn't get it on Black Friday, that's the cheapest it's gonna be. Like, let's try this again. Oh yeah, I knew it was logged in. Yeah, I knew that on Black Friday that item that's the cheapest that it was gonna be. What class is this? I guess it doesn't matter. Let me make sure I'm in the right course. Yeah, it's the right one. Yeah, and the reason I like the Ninja Blender, it has like the 3 blades, and so it makes it does a much better job. Was I working on this one before? Okay, this is fun. All right. So we're asked to identify the graph of the following quadratic function. So the base shape or the base function is a quadratic, which is a parabola. We have 3 transformations at play, right? That +1 tells us to go left 1, then the 2 tells us to do a vertical stretch by a factor of 2 and flip upside down. So the only one that went left 1 and is upside down is D. Okay, so with this one, if we're finding the quadratic function of this form that passes through this point, we can plug in this x and y and solve for a. So then -3 squared is 9. -36 divided by 9 is -4. So that means a is -4. -4x squared. Okay, let me get rid of this off. Notice that when x is -3, y is -36. Okay. Find the quadratic function of this form that has this vertex whose graph passes through this. So, I mean, we're really using the standard form of a quadratic. I'm just going to kind of talk through this one. If I need to write it out, just let me know and I will. Standard form is a times x minus h squared plus k, but our h and k in this case are both 0. So it's really going to take on the form like the previous example where it's basically ax squared because the vertex is at the origin. So then to solve for a, we're pretty much a repeat of the previous. 36 divided by 9 is 4. So in this case, our a is going to be 4. 4x squared. Okay. All right. Okay. But that one, again, that one was pretty much a repeat of the previous. Graph the given function by writing it in standard form. Okay, so here we should do completing the square. So completing the square is going to be b over 2 squared, and then we got to say plus or minus, right? So our b in this case is 4. 4 divided by 2 is 2. 2 squared is 4. So we're saying we're going to add 0 in the form of plus or minus 4. All right. So then long story short, we're going to get x plus 2 quantity squared plus and minus 4. Minus 4, right? Again, this comes out to completing the square. I didn't write everything out. If you need me to write it out, let me know and I will. Okay. So then in this form, this says that you start with a U-shaped curve, you go left 2 and down 4. Transformations. So 2 units to the left and 4 units down. Okay. Two units left and 4 units down. The vertex is there. Okay, let's see. We want to go left by 2 and down by 4. Okay, let's hit save. The vertex is -2, -4. Axis of symmetry is x equals -2. X-intercepts, I'm just going to look at the graph. This one is -4 and 0, so I'm just going to go with that. And the y-intercept, if x is 0, y is 0, right? The origin. Okay, let's keep going. Graph the given function by writing in standard form. Oh, so is it the same one? No. Let me write this one out. So let me get a copy of this and let's take some notes. Copy and delete. Okay, and let's hop over here. So yeah, that you can see the icon of the game I played. I only play like 2 games, maybe 3. Mobile Legends Bang Bang, that's what I play on here. And then I also play Dokkan Battle, Dragon Ball Z Dokkan Battle. And I came across this other random game. It's called Survivor IO, the IO or whatever. It's just a little character that runs around. Come on. It's like a zombie apocalypse, but it's just like you're running around and you get all these different power-ups and weapons and things. It's just fun. It's just something. But I discourage people, anything that like encourages you to spend money, I'm like, I don't like to push things like that because those things can be kind of addictive. They can, like, if you're not careful, they can mess you up. Okay, anyway. So we want to do this in the standard form, right? So we were given y equals, we got this 2x minus 5 minus x squared. Now, given something in this form, my recommendation is to put it in descending power order. So it's going to be y equals -x squared plus 2x minus 5. So that way it can look similar. Now, if we want to do completing the square, the first thing is the leading coefficient needs to be a 1, right? So I'm gonna factor out a -1 from every term. Okay. So then this is the same as a -1 times. Now we're gonna have this x squared plus 2x. I'm gonna put the -5 a little bit off to the side like this. So now for the completing the square, we do b over 2 squared. We're adding 0 in the form of plus or minus b over 2 squared. So we're going to say plus b over 2 squared and minus b over 2 squared, okay? Our b in this case is 2, so we're going to say 2 over 2 squared. We're adding that, and we're subtracting that, right? So we're adding 0 in this form, and what this allows us to do is to, it doesn't change our answer because we're adding 0, but it allows us to put our function in a form so that it can be factored, okay? So we have, this is completing the square. So that's plus 1 minus 1 minus 5, okay? So then from here, what we're doing is factor by grouping, okay? So the first 3, and let me, -1 minus 5 is -6. I'm going to distribute this negative. I want the negative times this first part and the negative times this. Okay, I gotta separate these guys apart. So then that's gonna give us a negative. We're gonna come back and factor this in just a moment. Okay. And then that's in the -6 times that original negative that we distributed becomes +6. And again, that came because I said a negative times these first three, and then a negative times those guys. Okay, and that's how I got that line. So then now one step away. This factors into x plus 1 quantity squared. Okay, I think we got it all. I think we caught everything we need to catch. Okay. All right. X plus 1 squared plus 6 negative. Okay. X plus 1 quantity squared plus 6. Okay, and that should be a y equals. Okay. And the reason, like, I feel I'm still like stuck on this blender. Like, it's, to me, it's such a good investment because, like, instead of going to like, what was it, tropical smoothie and spending nearly $20 for like a meal, a wrap and a smoothie, these smoothies might cost me maybe $2 to make, and it's like of equal or greater quality. Like, you know, because like basically I went to Arden's Garden and I would watch them make it. I'm like, they just using regular ingredients. They're not doing nothing special. So I was like, I can make that myself, and it comes out exactly the same. Like, it comes out exactly the same. Type in equation. Let me see. That's fine. We're gonna go with this now. We could check if we expand. We'd have x squared plus 2x plus 1 minus, wait a minute. Let me go back and check something. It should be a minus 2x. Right there. Yeah, I totally messed up. Right? Okay. I didn't factor out the negative. So let's go back. That changes a lot of different things. I'm glad I checked it. We would have got that wrong. Okay. So if I factor out the negative, that becomes positive. Right here, this should have been negative. Right? This should have been negative. And this should have been positive. Okay. So then with those changes, that means that this guy is negative. Okay, that's fine. That's fine. This should have been positive. So then with that 2 being negative, this is negative. So 5 minus 1, that turns this into a 4. All right, positive 4. Wait a minute. 5 minus 1 is positive 4. We distribute the negative, so it really should have been a negative 4 right here. Okay. And then that factors into x minus 1. Okay. And again, this should be a minus 4. And again, the only reason I caught it is because I checked it. I was like, well, let me expand it. I was doing it in my mind, and I was like, wait a minute. I think I got my signs wrong. And I totally did forget to factor out the negative, right? On that second that second line from the top, negative x squared plus 2 minus 5, right? Okay. So now let's go back and we got to fix things here. So I think that was x minus 1 and minus 4. And we're going to have to like confirm some things. So this was x minus 1 and this was minus 4. Okay. Minus 1 minus 4. So let's expand it really quickly to confirm whether or not it works. X squared minus 2x plus 1. Then it becomes a minus x squared plus 2x. And then minus 1 minus 4 is minus 5. Okay. So that feels, yeah. And again, only reason I caught it is because I was checking it before I moved on. I checked it. I was like, wait a minute, it's not adding up. Then I realized that I forgot to factor out that negative property. What kind of transformation occurs between the graph of the given function? Okay, so now from here, we can do transformations, right? This says you start with a U-shaped curve. We go to the right by 1. We flip it vertically, and then we go down by 4. So we said we go right by 1. So that's a horizontal shift. We flip it over the x-axis, and then we go down. So a vertical shift, right? Everything except flipping horizontally. Use the graphing tool to graph the function, okay? It'd be nice if I can get both of those to show. That's fine, I can't get it to work, so. Let's see, we said we went right 1 and down 4, right 1, down 4, okay. Right 1, down 4, and it's upside down. Okay, wait, I think we, because of the order we did it in, we need to do it, stop. Let's redo that because we need to do it in the right order. I think if you do it in the wrong order, it distorts the image. Okay. So we said we went right 1. Let's flip vertically. And then go down 4. Okay. So the order in which you do it doesn't matter. Okay. Let's see. So our claim is that when x is 1, y is -4. -3 minus 1 is -4. Okay. When, what's another one that we could test? It looks like 3 and -8. 6 minus 5 is 1. 1 minus 9 is -8. Okay. So the vertex looks like it's 1, -4. This thing is so temperamental. Parentheses 1, comma -4. Axis is x equals 1. X-intercepts. I like to use the standard form. So if we set it equal to 0, we add 4, divide by negative. So we get -4, right? So no x-intercept, right? Because it's upside down and then we went away from the x-axis, so it's not crossing the x-axis. So there are no x-intercepts. The y-intercept, if you set x to 0, the output is -5. Y-intercept is oftentimes easier. You just let x be 0. You're good to go. Wow. He looks high to me. Wow. Okay, let's see the time. Let's try to go for like another 10 minutes. Let's see. Okay. So does the parabola open up or down? The leading coefficient is a +1. So that means the graph opens upward. The vertex, so to jump straight to the x coordinate of the vertex of a parabola is going to be -b/2a. So -10 divided by 2 is 5. That's the x coordinate. So the x coordinate is 5. And then when x is 5, the corresponding y, 25 minus 50 is -25, -16. All right, -16. Okay. The axis of symmetry is x equals 5. Okay. The y-intercept, if we let x be 0, is going to be 9. Oh, and then the x-intercept. So for me, the x-intercept, oh, we don't have it. So what is that? -9 and -1. So 1 and 9. I think it's 1 and 9. We do need to check this, but I'm not checking it right now. 1, 9. Okay. Let's graph. We should put it in, like, it would be easier in standard form. So we got what? 1. No. I'm gonna have to move these around. Okay. Let's see the vertex. We said was what? 5 and -16. Okay. And then one of the intercepts is 1. Okay. I mean 9. Okay, I think this is good. This looks right. Said the wire intercept was 9. Yeah, it looks like everything checks out. Okay. Ooh. Let's keep going. Determine whether the given quadratic function has a max value or min. So the leading coefficient is a +1. That means our parabola opens upward, which means it has a minimum value. So then the minimum is going to occur at the vertex. So the x coordinate of the vertex, again, is the vertex formula, which is -b over 2a. So 10 divided by 2 ends up being 5. When x is 5, 25 minus 50 is -25. So I think that's what, 9? -9. So the minimum value is -9. So the range, if the minimum is -9 and the range is the very bottom to the very top, then this is going to be bracket -9 to infinity. Okay. I think that's it for that one. Ooh. All right, guys. Let me see. Let me check on you guys. Did you guys have any other questions? Did you want to do any more? I think I'm done. I can't focus. Let me try to do another one. So I'm done. Let me see. Determine whether the given quadratic has a max or min. Okay, so the leading coefficient is negative. That means our parabola opens downward, which means we have a maximum value. The max value is going to occur at the vertex. So the x coordinate of the vertex is -b over 2a. So -12 divided by -6 is a +2. So when x is +2, the corresponding y, let me see, you got -12. So then become +24 is a +12, minus 20 is -8. So then we're going to put -8. So, and that's, let me see, if it opens down, that's a what, max value? So the range is the very bottom to the very top. And if that's a max, then the range is going to go from -infinity up to 8. Okay. Consider this polynomial, write the degree of the polynomial. Okay. So the degree is the term with the highest exponent, is the highest power. So the degree in this case is going to be 5. The leading term is 2x to the power 5. The leading coefficient is 2, and the constant term is -6. Okay. Oh, I didn't mean to skip that one. Okay, so this one is not a polynomial function because of the presence of the absolute value. All right, so we're going to go A. This one is not a polynomial because of the -1. The polynomial is not a polynomial because the negative power of x. Yes, B. Match the following polynomial with its graph, use the leading term test and the y-intercept, okay? So because the leading coefficient is negative, that means our graph goes down to the right. because the degree of our polynomial is even, which is 6, which is even. That means the other side does the exact same. So it goes down to the right and down to the left. I think there's only one that goes down to the right and down to the left. And it looks like it's D, right? Y-intercept of -2. Let's just go with D. Next. Oh, wait. There's more. Oh, y-intercept is -2. Okay, let's see. So for the polynomial function, list the zeros. So for A, type the zeros. So fortunately, this was already factored for us, okay? So our zeros are 4 and -1, okay? What's the multiplicity of 4? So the power on the binomial containing the -4 is 1. So the multiplicity is 1. What's the multiplicity of -1? Is going to be 2. Okay. So if the graph, because the multiplicity of 4 is odd, that means the graph is going to cross the x-axis. Because the multiplicity of -1 is even, that means the graph is going to bounce off the x-axis. Okay, so that's from multiplicity, giving us a description of the graph. Okay. I mean, we should factor this, but I think I'm spent, guys. Okay, I think I'm gonna stop here. Did you guys have any questions that you'd like to ask? Any final questions?
Yes.
Okay, let me go ahead and
Yes.
go ahead. Yes.
Hello.
Yes.
Hi. I was wondering about the actually not last leaves. It's more personal, actually.
So,
Okay.
oh, personal question.
Yeah, it's more personal. Yes.
Okay. Let me stop the stream. Let me see what I got wrong here. Let's see. Interval notation has a max value. Maybe we just got the number wrong. Oh, we forgot to put the negative. Okay, that's fine. Yeah, we just forgot to put the negative. I think that was the only one that we missed. Okay. But let me make a copy of anything that you saw me writing. Let me make a copy of it available. It's in a box. One. So when this bar finishes loading, you'll get a copy of anything that you saw me writing. If there are there any questions that it's okay to be streamed? Did anybody have? If not, let me go ahead and stop the stream. Let me say this. Again, I am proud of you guys. It was a great semester. It's not easy, because the burden is on you guys. You got to show up. You got to be diligent, ask questions. You got to cross all your T's, dot your I's. That's a milestone. You're accountable for yourself. You did it. So I'm proud of you guys. Good luck with everything. I'm going to go ahead and stop the stream. We're going to end the session here, and from one beautiful mind to another. Enjoy the rest of your day, guys.